By now you've had a couple of presentations on motion and momentum in general. You've graphed your motion, and then you've had a presentation where we started throwing some math in there on you, some problems. Okay, so I want to demonstrate a problem-solving methodology that I'd like to see you follow the entire time we're doing motion and momentum, not only so you can all communicate the same way together, but it's able to be communicated outside and you can all work like that. So step one, I want you to section your workspace. Neatness counts, and I suggest top right for conventions and symbols. And I'll demonstrate all this in a minute. Step two, make a drawing. It helps to visualize and is a common reference between your audience, you and your audience. Step three, assign conventions. You may draw your car going left and your buddy draws his car going right. You need to decide where positive is for you. Step four, state what you need to know at the top of your workspace, so you can always refer back to that. Step five, list your knowns and unknowns with your chosen symbology separate from your workspace, again so you can refer back to it. Start with your starting formula, find a governing formula, and begin your work. Okay? So I'm going to do a simple problem here, and what I'm going to do is give you just a moment by pausing the video or looking at it up on the screen in class, and we're going to work that simple problem right there using this methodology, and I'll walk you right through it, and then I'll do a couple more samples in a future video for you. Okay? So take a moment and write that down. Okay, so here we have the problem stated on a blank sheet of paper, and I'm going to work the problem for you following the steps. Step one, section your workspace. Well, I'm going to work the problem and do the drawing over in this space. That means I'm going to keep track of my sign conventions and my abbreviations and stuff all over in this area up in here. Okay, so we'll start with that, and the next step, of course, is making a drawing. And you'll have to pardon Mr. Harrison's drawing ability. It's really kind of subpar, and all my cars end up looking somewhat like that. Okay, and so there's my little car, and I'm going to say that it's moving to the right. Okay, and that brings up the point about the sign conventions. Now we want to keep track of what's positive, because I said I'm going to draw mine going to the right, and that's in a positive direction. Not everyone draws their cars the same way, but we're going to assume that up and to the right is positive. We could change those conventions, as I've said before, but for the sake of standardization and for all of us to have a common understanding, in this class we're always going to say up and to the right is positive, and we're always going to put that in there for every problem, and you'll get credit for that. So there's a good reason to keep doing it the same way. So we look at what we have and we say that it starts from rest. Well, what does that mean? That means that its initial velocity is equal to 0 feet per second. Okay. Well, now we have some symbology that we need to start tracking, some variables. So V, we're going to say, is velocity. Okay? And we're going to come down here and say I is initial, right? Because we want to have a final, a time 1, a time 2, however we want to do it. We want to track that for ourselves and make sure we can follow that, and someone reading your problem can actually go back and forth and understand it themselves. Now it says it accelerates at a rate of 100 feet per second. So we're going to have an acceleration equal to 100 feet per second squared. And so we're going to need to track this acceleration as a variable. Okay, over there. And then it gives us two different time periods, right? 20 seconds and 3 minutes. So time period 1 is 20 seconds. And we're going to go ahead and say T is for time. Okay? 1 is period 1. And we're going to say this 3 minutes is a second time period. 3 minutes is 180 seconds. We need to keep our units standard, okay? If we're talking seconds in one part, we should be talking seconds in another part. Don't let me fool you with that on a test, okay? So that's time period 2. I forgot the 1 there, sorry. Right. So we have initial, time, period 1, period 2. I know already they're going to need a final, okay? subscript final, okay? So here are my conventions, as I said, partitioned off. Easy for someone to check on our paper and see that we did, in fact, track all of our abbreviations and stuff like that. There's just one more thing we're looking for, right? How far does the car go? Well, that's a distance, right? So I'll go ahead and put this up here. A distance. Now, does it need to be in this order? No, yours can be in any particular order that you want as long as you can track it and understand it, okay? So it asks us how far does it go? Final distance, that's why I have the final. That's what we're asked to solve, okay? We wrote that to the top of our page, and now we're going to write our initial equation and start from there. So what is that d final? Well, the d final happens to be the distance that the car travels during that first period and the distance that the car travels during that second period, because the car does have different velocities during those periods. So we do have a time final, but we don't really need to look at that, right? So we're going to use our formulas, and the formulas that you're familiar with, that you've been given on your page, are these, okay? Distance is equal to velocity initial times time plus 1/2 the acceleration times the time squared. And that's just the general formula, okay? And I think I need to just slightly adjust my page here so we can follow that. So what we want to do is consider each one of these time periods separately. So we'll do the first time period first. d1 is equal to the initial velocity, okay? And what's the initial velocity? That's a 0. Doesn't matter if you multiply it by time, it's still a 0 because we said it was 0. Plus 1/2 the acceleration. What's the acceleration during that initial time period? It's 100 feet per second squared times the time squared. What's the time? 20 seconds squared. Okay, if you'll do your calculations, you take the 20 and you square it, multiply it out by that 100, divide by 2, and then you're doing your unit cancellations, right? That second squared divided by second squared cancels out, and so you're going to get an answer of d1 is equal to 20,000 feet. So that's how far it goes when the car is accelerating. So we have to do that same thing again. It stops accelerating at that point, right? So d2, okay, is equal to velocity during that second time period, okay, because once it accelerates, then it has a velocity, times time plus 1/2 the acceleration times the time squared again. But now, during the second time period, this acceleration is 0. So we don't have a term here. That's just 0. So now all we need to find out is that velocity times the time. Well, what is that velocity? How do we figure that out? Okay. Well, all we have to do is realize that acceleration is equal to nothing more than the change of velocity over time. We've talked about this, right? And that change of velocity over time is just the final velocity minus initial velocity over time. What's the initial velocity? That one's 0, okay? So rearranging, we take the acceleration times the time and we'll get the final velocity. Acceleration times the time is equal to the final velocity. Okay? The velocity for that one, okay, is equal to 2,000 feet per second. And that's the same thing as V2 that we're using over here. Okay? So that second distance then is nothing more than 2,000 feet per second times 180 seconds. That second time period, remember? Okay? And D2, then by doing your math, canceling your units, ends up being 36,000 feet. So the final as we said, is D1 plus D2. D1 is 20,000 feet plus D2, 36,000 feet, and that's 56,000 feet. There you have your answer, and you'll see it's always best to kind of box your answer or maybe draw an arrow to it. Some people like to star it. However you want to do to draw the reader's eye to your answer so they can follow it. And if you have any questions, you can ask your teacher and he'll help you out.